Hey team, welcome back to my channel. In this video, we're going to multiply two matrices. We will learn if two matrices are compatible for multiplication and determine the result matrix size after multiplying two matrices. Are you ready for this? Let's do it. Let us multiply these two matrices. To test to see if two matrices are compatible for multiplication, we need to make sure the number of columns in the first matrix is equal to the number of rows in the second. Write down the two matrices on a piece of paper like you see above. Use the goalpost symbol to identify the appropriate value. Then ask yourself, are they equal? If they are equal, they are compatible, and you can multiply these two matrices. The size of the result matrix when multiplying two matrices is determined by the number of rows in the first matrix by the number of columns in the second matrix. Let's use the first row of matrix A to be multiplied with the first column of matrix B. Notice A11 times B11, or 5 times 8. Then we move to the next column in matrix A, and we're at A12 times B21, or 3 times 7. And lastly, A13 times B31, or 2 times 9. Let's add up the parts, giving us 79 for C11. Now let's add the first row of matrix A to be multiplied by the second column of matrix B. Notice A11 times B12, or 5 times 12. Then move to the next column in matrix A. A12 times B22, or 3 times 0. And lastly, A13 times B32, or 2 times a negative 3. Now let's add up the parts, giving us 54 for C12. Let us solve C21. It all begins with matrix A. We're now on the second row, times matrix B, the first column. We're going to take 4 times 8 plus 6 times 7 plus negative 1 times 9. That sums to 65. And that's C21. Let's now solve for C22. Are you starting to see a pattern on how multiplying matrices work? Well, let's finish this one up. We're going to be taking the second row of matrix A times the second column of matrix B. So that is a 4 times 12 plus a 6 times 0 plus a negative 1 times a negative 3. Adding up those elements, you see we get 51. And there you have multiplying a 2 by 3 times a 3 by 2. Look down here on line 30. Notice that we're doing a 2 by 3 matrix times a 3 by 2, and we're making sure that our sizes are compatible. And notice it gives us 3 equals 3. So yes, these are two compatible matrices. Now notice here on line 8, what we're saying is, see how I gave an open bracket and then another set? Well, this makes that two-dimensional. So here you can see that we have a two-dimensional array. The data type is integer. On this one right here, we have 2 by 3. And here you can see that we have a 3 by 2. You can see here I'm going to be using NumPy, numpy.matmul, mat matrix, MUL multiply, so matrix multiply A comma B, the two-dimensional arrays we defined above. This function returns us results. Notice on line 23, we will call the function printHeader. It has 2 arguments, a title for contents and then a defined width. This function defines the segment in the output window for easy recognition of the work performed. Then I'm going to print out A, your two-dimensional array. I'm going to print out your two-dimensional B matrix, and then R is the result. Let's run this and see what happens. And notice right away that we can see The results are going to be 79, 54, and 65 and 51. And there you have it, team. We just finished multiplying two matrices, a 2 by 3 by a 3 by 2. We made sure that these two matrices were compatible. Think about lining up that goalpost symbol on the appropriate columns, and then how to determine the output matrix size. If you have any questions or comments about this video, or just want to share your experience, please leave them below. I hope you were able to learn a thing or two, and I'll see you back in my next video. Take care.